So in this video, I'm going to go over the performance exam review. You should be keeping in mind that you guys should go back and look over your notes if there's something you're not understanding as you're looking through this review. We're going to take this performance exam excuse me, on Tuesday when we come back from Thanksgiving break. In addition, by Monday, you're going to have to, at the end of the day, 2:05, you have to complete the Google form, which basically states which unit questions you're going to do. So if you don't choose by that date, then I'll randomly assign one to you or your teacher will. So the performance final is 5% of your grade, your overall grade, but then it can also replace a lower test grade on the unit that you choose. So say, for example, there were 2 tests for Unit 3, and you made a 55 on one and a 70 on the other, and you make an 80 on the performance exam, then you could replace that 55 with the 80. Not both, but one of them. So one of the unique things about a performance exam is that you're going to have to explain everything you do. So most of your grade will come from your written explanations. So we're going to start out by doing this Unit 2. And when you're looking at Unit 2, review the operations with polynomials, adding, subtracting, multiplying, and dividing, and then review Pascal's triangle, and then make sure, again, that you can explain every step of the problem. Okay, so we're going to go ahead and work this number 1 here, and we're going to multiply. And I'm going to use the box method to do this. So I went ahead and drew a box, and now what I'm going to do is I'm going to put these terms on the outside. So I'm going to put my 2x and my -5 over here, and I'm going to put my 2x squared and 8x and -6 up here. And remember, if you write these in descending order, then in your diagonals, you're going to find your like terms. So we're going to go ahead and do 2x times 2x squared, so that's going to give us 4x to the third. Then we're going to multiply 2x squared times -5, so that's going to give us -10x squared. Then we're going to do our 8x times our 2x, that's going to give us 16x squared. Then I'm going to multiply 8x times -5, that's going to be -40x. Then I'm going to multiply the -6 times the 2x, that's going to give me -12x. And then down here on the bottom right, -5 times -6, that's going to be 30. So now all we have to do is look at, and you can see, because I did it in colors, the diagonals have our like terms. So now I'm just going to write the answer down here. So I'm going to combine our like terms when I'm doing this. So we're going to do 4x to the third, and then we're going to add the -10x squared plus the 16x squared, so that's going to give us 6x squared. Add the -40 and the -12, that's going to be -52x, and then the 30. So recall that the directions say that we have to explain. So this is what I wrote. Use box method to multiply the 2 polynomials, and that the diagonals are like terms, so combine like terms. So that's, remember, you're going to have to type or write out your explanations to these problems as well. So number 2 was a division problem. So I'm going to use the long division to do this. So I'm going to basically put the 4x to the third minus 6x squared. Remember, we had to put a space holder where the x the first is, so we're going to put 0 plus 0x, and then plus 8. Then we're going to divide that by x squared plus 4. So what do I have to multiply x squared by to get 4x to the third? That's our question. So I have to multiply that by 4x. So when I multiply 4x times x squared plus 4, that's going to give me 4x to the third plus 16x. Now I'm going to take that 4x and put it up here because that's what I multiplied the x squared by. And then I'm going to put the 4x to the third plus 16x over here. Now remember, we're subtracting this, right? So that means both of these terms are going to end up being subtracted. So that term goes away, and then we move down the -6x squared and minus 16x. I'm going to go ahead and bring down this 8 as well. So once again, what we want to do is figure out what do we have to multiply x squared by to get -6x squared, and that would be a -6. So we're going to multiply that again by our x squared plus 4. That's going to give us -6x squared minus 24. So we're going to put this -6 up here again, and I'm going to put this term underneath here that we just created, negative 6x squared minus 24, keeping in mind once again that we are subtracting this. So if we're subtracting the whole term, then that's going to make that a plus and that a plus. And again, our first term is going to go away. We're going to be left with negative 16x. When we add 8 to 24, we get 32. This is our remainder, so we're going to put our remainder over what we were dividing by. So we're going to add to this a negative 16x plus 32 and put it over our x squared plus 4. Now once again, what I said was I'm going to multiply the x squared plus 4 times 4x to get 4x to the third, subtract the term that I got, then multiply x squared plus 4 times negative 6, subtract that term again, and put the remainder over x squared plus 4. So that was my explanation. So for number 3, we're going to use Pascal's triangle to expand x minus 7 to the fourth. So I'm going to do Pascal's triangle up here first. And if you remember, the first and last numbers in every row in Pascal's triangle are 1. So we're going to do a 1 here, and then we're going to add the 1 plus 1, so that's a 2, and end with a 1. We're going to do 1 here again, and add 1 plus 2, that's 3. And 2 plus 1, that's 3, and end with a 1 again. And then we're going to do 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we're ending with 1 again. Now, because this is a fourth power, we're going to use our fourth row. So that means we're going to use this row right here of coefficients to do our problem. So I'm going to go ahead and write that first. And I'm going to do 1, 4, 6, 4, and 1. And then I'm going to take this term right here, this x, and I'm going to put it in a first set of parentheses. Okay, now if you recall, we're going to take this fourth power, we're going to write it in descending order here. So 4, 3, 2, 1, and 0. Now we're going to take this negative 7 right here, and we're going to put another set of parentheses. And this time we're going to go up with our fourth. So we're going to go 4, 3, 2, 1, 0. Now, what you should notice is that when I add those exponents, 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4. They should always add up to be 4, and if they don't, then you've messed up somewhere in your setup, okay? So now all we have to do is simplify the terms. So that's what we're going to do next. So we're going to multiply 1 times x to the fourth times 1. Okay, so this is going to be 1 x to the fourth times 1. So that's going to be x to the fourth. Our next one is going to be 4, and then we have x to the third, and then we're going to multiply by the negative 7. So this one's going to be negative 28 x to the third. The next one, 6 times x squared times 49. Oops. So on this one, we're going to get 294 x squared. On our next one, we're going to get 4 times x. And when I take negative 7 to the third power, that's going to get me negative 343. And then when I multiply the 4 times the negative 343, I get 1372, and again times x. And on our last one down here, we have 1 times 1. And then when we take negative 7 to the fourth, we get 2401. So then to write our answer, all we have to do is put these terms together. So we have x to the fourth minus 28x to the third plus 294 x squared plus, wait a minute, no, this was supposed to be minus, y'all. That should have been a minus, because when you take a negative number to an odd power, it should always stay whatever the sign it was. So this is going to be minus 13. I can't write. 1372x, and then plus 2401. So that is x minus 7 expanded. So what I wrote this time was, I said put the fourth row of Pascal's triangle as a coefficient, then put x and negative 7 as the terms, put the x's in descending order from 4 to 0, and put the -7 in ascending order from 0 to 4, and then simplify everything. So with number 4, it says, given that you have x to the third minus 3x squared minus 9x minus 5, use the fundamental theorem of algebra to determine the number of zeros in the function. So if you recall, we use the degree of the polynomial to determine the number of zeros. So the degree has to do with the highest exponent, and that would be this third right here. So it's a third degree polynomial. So that means that it's got 3 zeros. So when I write my explanation, I'm going to say the fundamental theorem of algebra states that the number of zeros is equal to the degree of the polynomial, which is the biggest exponent. Thus, there are 3 zeros. So on this next screen, where it says, given, again, the same equation, find all the zeros and state the multiplicity. So on this one, we need to graph this. So you're going to actually need to put that equation in your calculator or use a program like Desmos to look at the graph. And then I went ahead and drew the graph that this looks like. So notice that this graph intersects the, and this is the x-axis right here, y'all. This is the x-axis. And that's the y-axis right there. So it intersects the x-axis at -1, and it bumps it. So we're going to say that x is equal to -1. That's one of our zeros of the function. And this time, this is an even multiplicity. And then it also intersects over there at 5. So x is also equal to 5. And this one is a multiplicity of 1 because it slices. Now, I'm going to show you guys what one would look like if it had been an odd multiplicity. So if I had the graph coming up like this and it slid along there like that and then went up, that would have been an odd multiplicity. But that's not what this particular graph looks like. But that's what an odd multiplicity would look like. So this is what I wrote for this one. This equation has a zero of at x equals -1 with a multiplicity of 2 because it bumps, or a multiplicity of even because it bumps the x-axis. It also has a 0 at x equals 5 with a multiplicity of 1 because it slices through the x-axis. So now we're going to go into our Unit 3 problems. So our first problem was 2 complex equations, or actually 4 complex equations multiplied by each other. This one says write each complex number in standard form. Remember, standard form is a plus bi, so it has the real part first and the imaginary part second. So show your work and explain your steps. Is your answer a real number, imaginary number, and explain why. Okay, so when I did this problem, I went ahead and just multiplied the first 2 complex numbers by each other. So I did the 4 plus the I times the -3 minus 2i. So when I did that, I got -12 minus 8i minus 3i minus 2i squared. Remember, when I'm doing outside, you could use the box method here, but I'm using FOIL. So now I'm combining like terms. So I got my -12 minus 11i. And now I'm going to go ahead and change that I squared to a -1. So I'm going to change this to a -1. Then I'm going to combine our like terms. So -12 plus 2 minus 11i. So that's going to be minus 10 minus 11i. So I did the first 2 equations first, and now I'm going to do the second 2 equations. -2 plus 5i times 4 minus 8i. So again, I'm using FOIL here. First outside, inside, last. -8. You could use the box method if you wanted to. So this is the inside, outside, inside. So this is the inside. And then minus 40i squared. Again, combining like terms. So that should have been plus, yeah. This was 36i minus 40i squared. Going to change that I squared to a negative 1. So I got negative 8 plus 40 now, plus 36i. So that's going to give me 32 plus 36i. Now what I need to do is take these two terms and multiply them by each other. So that's what I'm going to do next. I'm going to do negative 10 minus 11i times 32 plus 36i. Let me go ahead and extend my page down here a little bit so I have some more room to work. So it's going to give me, again, first outside, inside, last, negative 320 minus 360i minus 352i minus 396i squared. So again, combining like terms, I've got my negative 320 and then minus 712i minus 396 times that negative 1, again changing that I squared to a negative 1. And so keep simplifying, that's negative 320 plus 396 minus 712i. So our final answer is 76 minus 712i. Now, when I wrote my explanation for this, I said multiply first two binomials and second two binomials together, then multiply the resulting binomials together, keeping in mind that I squared is negative 1, so I'm going to change I squared to negative 1 every time, and I'm going to combine like terms. And this question asked us if this was a real or imaginary answer, and this would be an imaginary answer because it's a complex number. The 76 is a real part, the negative 712i is the imaginary part because it has I in it. So on this next problem, it says that we should simplify this. So what you have to recognize when you first look at this problem is that we have a complex fraction here. So we have a complex number over a complex number. So what we have to find is the complex conjugate of the denominator. So the complex conjugate is going to be, we're going to change the imaginary part's sign. So we're going to do 2 plus 4i, and then we're going to put that over 2 plus 4i, and we're going to multiply those. That's going to enable us to get rid of that imaginary number in the denominator, which we can't have because I is the square root of negative 1, and we can't have a radical in the denominator. So what we want to do now is just multiply across top and across the bottom. So we're going to do FOIL again. So when we do that, we're going to get 14 plus 28i minus 6i minus 12i squared. And then in the denominator, we're going to get 4 plus 8i minus 8i minus 16i squared. So we're going to keep simplifying this. So we're going to combine some like terms. So we get 14 plus 22i. Now we're going to again go ahead and change that I squared to a negative 1. And then down here, notice that the 8i and the negative 8i cancel each other out. So we're going to do minus 16 times a negative 1. So again, we're going to keep simplifying here. So we're going to have 14 plus 12 plus 22i over, this is going to be 4 plus 16. So I'm going to have to go to the right here. So that's going to give us 26 plus 22i over 20. Now hopefully all of you can see that 2 goes into all of these numbers. So we're going to GCF this, and so it's going to be 13 plus 11i over 10. And that's our answer. So again, when I wrote my description here, I said multiply complex fraction by the complex conjugate of the denominator over itself. Change I squared to negative 1 and simplify the numerator and denominator. And they are both divisible by 2. So when doing number 8, what we need to consider is that we have like terms here because all we're doing is adding and subtracting these terms, okay? So what we're going to do is we're going to put all our real parts together and notice this minus sign here. So we're going to change the signs of whatever's there. Okay, we're going to combine all those terms, and then we're also going to do our imaginary parts. So we're going to do our 3i plus 7i, and we're going to do minus a minus 2i. I kind of like doing it that way, y'all, because then I make sure I don't make a mistake. And so I know that when I change the sign and change what's behind, if I have two negatives together, it actually ends up being a positive, right? So we're just combining like terms here. Then negative 6 plus 2 is negative 4, and negative 4 minus 4 is negative 8. So we got negative 8 here, plus 3 plus 7 is 10, plus another 2 is 12. So that's our answer right there. Just recall, so again, we're going to combine like terms here, and then we're just going to write our answer in standard forms. That means the real part's going to come first, and the imaginary part's going to come second. And oh, in the question before, the answer was still imaginary because it had an I in it, and so is this one for the same reason. So on this problem, it says solve for the variables x and y that would make the equations true. So what we want to do is put the imaginary parts with the imaginary parts. Notice this one has an I and this one has an I. So we're going to do negative 12xi equals 36i. So we got our x on the left, and we need to get everything else on the other side of the equation. So we're going to divide this by negative 12i and this by negative 12i. So when we do that, what you should notice is that everything over here cancels out, right? Except for the x. The i's cancel out. So we're just dividing 36 by negative 12, so that's going to be negative 3. Then we're going to deal with our real parts. Those are the parts that don't have I attached to them. So we're going to do 6 is equal to 24y. Again, divide both sides by 24. 6 over 24 reduces to be 1/4. So when we're writing our description for this, we're going to say set the imaginary parts equal to the imaginary parts and then solve it. Set the real parts equal to the real parts and then solve it. So this one, number 10, says rewrite the rational exponent in rational exponent form. So on this one, all we have to do is take this 3n, and remember the index is the denominator. So that means this right here, it goes in the bottom, and this right here is our numerator. So that's all you have to do with this problem is say 3n to the 3/5 power. Remember, so when you're writing this, I say the index is the denominator and the power is the numerator. So that's how you're going to switch this one. So now we're on our questions for Unit 4. And this says, again, review solving factors, solving by factoring, quadratic formula, completing the square, and graphing. You should be able to solve something like x squared plus 20x equals negative 100, and 6x squared minus x minus 12 equals 0 using multiple methods and be able to explain your steps. Okay, so we're going to go ahead and work our a here. So that's going to be x squared, and we're going to do this by factoring, plus 20x. Now my first thing I'm going to do is move that 100 to the left, so that's going to be plus 100, and I'm going to set this thing equal to 0. Recalling that we're going to multiply our first and last term, so that's going to be 100x squared. And because we have an x, we're going to take the square root of that x squared. We're going to just put the x here, x and x, right? And then we're thinking about what are the factors of 100 that when added together give us 20. So that's going to be plus 10 and plus 10. And again, this is equal to 0. And we're solving this, so we're going to set these factors equal to 0. Well, in this case, we really only have one, so we're going to do x plus 10 equals 0. So x equals negative 10. And now we're going to do b over here. So we've got 6x squared minus x minus 12. This one's already in standard form. So here again, we're going to multiply our first and last. It's going to give us negative 72x squared. Now this one's a little different because we're going to bring our coefficient into our set of parentheses with us. So we're going to put our 6x here and our 6x here. And then again, we're thinking about what are the factors of negative 72 that when added together give me a negative 1. Okay, so that would be 8 and 9. Sorry, 8 and negative 9. So when we're doing this, remember we're always trying to see if there's a GCF, and there is here, it's 2. So on this one we're going to get 3x plus 4. That's one of our factors. And over here we have a GCF of 3. So that's going to give us 2x minus 9. Again, those are equal to 0. So we're going to set each of these equal to 0. I'm going to go ahead and put 0 over here. So that's going to give me negative 4 equals 3x. Divide both sides by 3. So that's one of our answers there. And then over here, same thing. We're going to add the 9. So 2x equals positive 9. Wait, 9? No, that was wrong. Sorry. Hopefully y'all caught that. This should have been negative 3. So that means this is 3 right here. So now we're going to divide both sides by 2. And that's our other factor right there. So when I wrote the description for this, it was kind of long. I said, first of all, I'm going to put everything in standard form, which is ax squared plus bx plus c equals 0. Then I'm going to move the constant to the left of the equal sign. I'm going to multiply the first and last terms and find the factors that combine to equal our b right here. Then on the left, once we found those factors, then we set those factors equal to 0. But on the right, when we're figuring out what we put in our parentheses, we put an x and an x in the left, but on the right, we put the coefficient with the x. And then we also have to GCF out what we got. We got a GCF out the 6x plus 8 and the 6x minus 9. Then we set our factors equal to 0 and we solve. So here again, I'm going to use my standard form of the equation ax squared plus bx plus c equals 0. So we're going to put these in standard form first, and then we're going to use the formula, the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to give our x values, okay? So the first thing we're going to do here is we're going to write this in standard form, and we're going to say what a, b, and c are. So we've got x squared plus 20x plus 100 equals 0. So a equals 1, that's what's in front of the x squared. B equals 20, and c equals 100. Now, when I did this, I always do I do the discriminant first. So I do b squared minus 4ac first. So I'm going to do 20 squared minus 4 times 1 times 100. So that's going to give me 400 minus 400, which is equal to 0. So that's kind of nice, because then I don't have to worry about what's underneath the radical. So we're going to now go negative b, which is negative 20, plus or minus our 0 over 2 times 1. So that's going to give us negative 20 divided by 2, which is equal to negative 10. And this time we do get our solution. When we use a quadratic formula, it just gives us the solution. We don't have to set it equal to 0. Now let's go ahead and do our b up here. So with b, it was already put in standard form. So we got 6x squared minus x minus 12 equals 0. So a equals 6, b equals negative 1, and c equals negative 12. So here again, I'm going to do what's under my radical first. So I'm going to do negative 1 squared minus 4 times a, which was 6, times c, which is negative 12. So that's going to give me 1 plus 288. That's equal to 289. Now, recalling that we have to take the square root of this 289, right? Because that's what we have right here. Y'all see this radical right here? And we're going to have plus or minus in front of that. So this is going to be plus or minus. The square root of 289 is 17. So this is going to be plus or minus 17. So again, we're going to do negative b. So we got minus 1 plus or minus 17 over 2 times 6 this time. So this is going to be 1 plus or minus 17 over 12. So that would be 1 plus 17 over 12. That's going to be 18 over 12. That's going to reduce to be 3/2. And then we've got 1 minus 17 over 12. So that's going to be a negative 16 over 12. DCF of 4 for both of those. So that's going to be negative 4/3. So same answers we got the first time. There's our 3/2 right there. And then our negative 4/3. Okay? So again, what I wrote for this was move C to the left of the equal sign or put the equation in standard form. Find A, B, and C from the equation. AX squared plus BX plus C equals 0. Then plug the values into the quadratic formula and simplify. So this next set of problems says solve by completing the square. So on this one, we're going to do x squared. This is our A. Plus 20x. Again, move that 100. Well, actually, we can leave the 100 where it is this time. Plus blank equals negative 100 plus blank. This is the way I do it. So we're going to take this b, which is 20, and we're going to do 20 divided by 2. That's going to give us 10. So then when we put down here in a parenthesis, we're going to say x plus 10, and that's going to be our term squared, which is why it's called completing the square. Now we're going to take this 10 and we're going to square it, and that equals 100. And that's what we're going to put back up here in this blank, okay? So then we're going to combine what's on the right here, which negative 100 plus 100 is actually 0. So we're going to then take the square root of both sides here. So that's going to give us x plus 10 equals 0. So x is equal to negative 10, which is what we got before. So then now we're going to do b. So I'm going to do b over here. So this is going to be 6x squared minus x plus blank equals negative 12 plus blank. Well, I'm not going to use this for completing the square. And the reason is, number one, because a does not equal 1. And do you notice that b is equal to negative 1, and that's not an even number, so I don't want to divide that by 2. I could do this, y'all, but it's ugly, and I'm not going to choose to if a does not equal 1 and b is not even, okay? So I want b to be even for this one, and I want a equal to 1 when I'm doing the completing the square, okay? So when I wrote the description for this one, I said, where did I do it? Create 2 blanks for C on both sides of the equal sign. Divide b by 2, then square b over 2, or b divided by 2. Put back in both blanks and put b divided by 2 in the parentheses with x plus or minus something squared as the second term. Take the square root of both sides and then simplify. So now we're on unit 5, and this should look really familiar to y'all because we just did this unit. So this says solve for a rational equation, state the restrictions, explain each step in the reasoning, use complete sentences. All right, so on this one, remember, we're always going to factor first. That's always going to be our case, okay? So we're going to factor what's in the numerator, so that's going to be 5 times x plus 5. And we're going to factor down here. This is x, and take square root of 25, we get 5 and plus and minus, right? Then times, we're going to go ahead and factor this numerator up here. So what are the factors of 9 that when added together give me 6? That would be plus 3 and plus 3. And then down here, we're going to factor out that 5. That's going to give me x plus 3. So hopefully now you see that all we need to do is cancel out the terms that are repeated in the numerator and the denominator. So we do have a 5 there and a 5 here, an x plus 5 there, an x plus 5 there, an x plus 3 there, and an x plus 3 there. So the only thing that's left is the x plus 3 and the x minus 5 in the denominator. So that's our answer. Now recall, when we're talking about restricted values, or what can we not have, so we're going to set every factor that was in the denominator equal to 0. So we're going to do x plus 5 equals 0. So x cannot equal negative 5. X minus 5 equals 0. So x cannot equal 5. And then we got this x plus 3 equals 0. So x cannot equal negative 3. So this is also part of our answer here because these are the restrictions that apply to this problem. So when I wrote the description for this problem, I said factor the numerators and denominators, cancel out factors that are repeated in the numerator and denominator, and then set the factors of the denominator equal to 0 to state the restrictions. So hopefully with number 15, you can immediately recognize that this is a division problem because that symbol right there is division in this problem. So what we're going to do is keep the top term, which is 7x minus 28 over 8x plus 32. We're going to change the sign, keep, change, flip, change it to multiplication, and we're going to flip what was in the denominator of this problem. So it's going to now be x squared plus 13x plus 36 over 4x squared minus 16x. Now we're going to do the same thing we did with the previous problem, which is factor the numerators and denominators. So 7 is factored out of that, so that's going to be x minus 4. Here, 8 can be factored out of that, so that's going to be x plus 4. Then we're multiplying, so this numerator up here, we've got an x and an x. What are the factors of 36 that when added together give you 13? That's going to be plus 4 and plus 9. We're going to factor our 4x out here, and that's going to give us x minus 4. So what do we do again? We cancel out what's repeated in the numerator and the denominator. So we've got an x minus 4 here, x minus 4. We've got an x plus 4 there, x plus 4 there. So I'm left with, in the numerator, 7 times x plus 9 over 8 times 4x. And your answer could be written the way it is here, 7x plus 9. You could simplify what's in the denominator, but you don't necessarily have to. We'll give it to you if you just leave it factored. So this would be 32x. Okay? So again, what I wrote for description for this was keep the top term, then change the sign from the division to multiplication. Then flip the bottom term, factor the numerator and denominators, eliminate factors that are repeated in the numerator and denominator, and simplify. So the key to 16, because we're adding rational expressions, is we have to get a common denominator. So that's going to be our first step on this problem. So we're going to multiply the x over x minus 2 by x minus 5 over x minus 5. So, and then we're going to multiply the 3 over x minus 5 times x minus 2 over x minus 2. Now we have common denominators, and once we have common denominators, we can simplify the problem. So x times x is x squared, negative 5 times x is negative 5x, 3 times x is 3x, and 3 times negative 2 is negative 6. Now all of that is now over x minus 5, x minus 2. Now we need to simplify what's on top, so we get x squared, what is that, minus 2x minus 6 over x minus 5, x minus 2. So we're asking ourselves here, are there any factors of negative 6 that when added together give us a negative 2? And the answer to that is no. So this is as simple as it gets. Now recall again, we have to talk about our restrictions. So we're going to set our factors, x minus 5 equal to 0. So x cannot equal positive 5. And x minus 2 equal to 0. So x also cannot equal 2. So those are our restrictions there. Let me go ahead and get rid of that plus so you guys can just see the 5. So x cannot equal 5 and x cannot equal 2. So this is what I wrote for the description for this one. Must find a common denominator to add terms. So we multiply the first term by x minus 5 over x minus 5. Multiply the second term by x minus 2 over x minus 2. And then we simplify by multiplying what's on the top, and then we can't simplify the x squared minus 2x minus 6. Then we also set our factors equal to 0 that were in the denominator, and those are our restricted values. So with number 17, what we're going to do first is factor what's in the numerator. So we're going to do x and x. What are the factors of negative 35 that when added together give you a negative 2? So that would be minus 7 and plus 5. We're going to put that over our x plus 5 and set that equal to our 15. So hopefully you can immediately see that we have x plus 5 in the numerator and the denominator. So we're going to cancel that out. We're going to be left with x minus 7 equals 15. Add 7 to both sides. So x is equal to 22. And again, we always want to find out what our restricted value is, so we're going to set our x plus 5 equal to 0. So x cannot equal negative 5, and it doesn't. So that's our answer right there. So this is what I wrote for this one. Factor the numerator. X plus 5 cancels out because it's in the numerator and the denominator. Add 7 to both sides, and there is a solution because 22 does not equal negative 5. We also want to set our denominator, the factors of our denominator, equal to 0, and that tells us our restricted values. And in this case, it doesn't cancel out our 22 because it doesn't equal 22.